So atomic spectra means collection of radiation lines. Okay. Yes. So there are two type of spectra. One is absorption spectra, another is emission spectra. Okay. So absorption spectra. Then you have emission spectra. तो सपोज मान लो आपके पास इलेक्ट्रॉनिक एनर्जी लेवल है, ठीक है, और आपने कुछ बाहर से अपने कुछ फोटोन को इंसिडेंट किया, ठीक है ना, फोटोन हैविंग डिफरेंट डिफरेंट एनर्जी। तो इलेक्ट्रॉन जो है लोअर स्टेट से यहाँ से जा सकता है, ठीक है, और कोई करस्पॉन्डिंग एक वेवलेंथ के कारण, दूसरा एक जो वेवलेंथ है और एनर्जी इनकमिंग फोटोन का, उसके कारण यहाँ जा सकता है, ठीक है, यहाँ पे भी जा सकते हैं। तो जब आप फोटोन एब्जॉर्ब करके इलेक्ट्रॉन लोअर स्टेट से अपर स्टेट में जाएंगे तो फिर स्क्रीन में क्या देखा जाएगा, जो वेवलेंथ एब्जॉर्ब हुआ है वहां पे क्या देखा जाएगा, डार्क स्पॉट देखा जाएगा, डार्क लाइन, ठीक है, एक्चुअली डार्क लाइन होगा, ठीक है। तो ये है आपका एब्जॉर्प्शन स्पेक्ट्रा। तो एब्जॉर्प्शन स्पेक्ट्रा में क्या होता है, बाहर से आप लाइट सेंड करते हो हैविंग डिफरेंट डिफरेंट फ्रीक्वेंसी। अब इसमें क्या हो जाएगा, लोअर स्टेट का जो इलेक्ट्रॉन है अपर स्टेट में क्या हो जाएगा, एक्साइटेड हो जाएगा। तो बेसिकली जो इनकमिंग फोटोन है वो एब्जॉर्ब हो रहा है। तो जब स्क्रीन पे देखोगे तो जो जो वेवलेंथ एब्जॉर्ब हुआ है वहां पे क्या मिलेगा, डार्क लाइन मिलेगा, ठीक है। और दूसरा क्या है, इमिशन स्पेक्ट्रा। इमिशन स्पेक्ट्रा इसका ऑपोजिट है। तो ये जो स्पेक्ट्रम मिलेगा बेसिकली डार्क मिलेगा, ठीक है। इमिशन स्पेक्ट्रम में इसका एग्जैक्टली ऑपोजिट होगा। सपोज मान लो इलेक्ट्रॉन आपका कोई हायर स्टेट पे है, तो इट कैन जंप हेयर, so it will give some photon. It can jump from this state to this state, it will give some energy or photon having different energy. It can jump from here to here, it will give some another photon having different energy. It can jump from here to here. So like that, from every excited state it can jump and it will give some different energy or different wavelength. So if you see this line on the screen, you will get that bright line. So this collection of these lines basically known as spectra. Okay, so this line will be for emission spectra, it will be bright, ठीक है। अब मैं एक क्यों बता रहा हूँ आप लोगों को, क्योंकि हम लोगों ने डिस्कस करूंगा पहले लीमान बामार पास्चन सीरीज, देन विल सॉल्व प्रॉब्लम। ओके, शैल आई इरेज? ओके,
यस सर।
सो मैं इन जनरल बता रहा हूँ हाइड्रोजन लाइक और हाइड्रोजन सेम के लिए, हाइड्रोजन लाइक एटॉम के लिए। सपोज मान लो आपका इलेक्ट्रॉन जो है EI स्टेट पे है और वो EF स्टेट पे गिर रहा है ना, वेयर EI इज ग्रेटर देन EF, ठीक है। तो इलेक्ट्रॉन इनिशियली एक्साइटेड स्टेट से इस स्टेट में है, व्हेन इट जंप फ्रॉम दिस स्टेट टू लोअर स्टेट EF, it will emit some photon, right? So it will have some energy. So energy of this photon will be how much? Delta E equals to h nu, that will EI minus EF, because EI is high here or higher than EF. So if you solve it, let us define this state is NF and this state is NI. So if you calculate this energy, it will be how much? Minus EI, okay, EI into Z square 1 by Ni square minus 1 by Nf square. Just I have substituted this value. You know that energy of nth state is nothing but E1. E1 means ground state. So here this E1, this is not EI, this is E1. E1 into Z square by N square, right? Here this is not EI, this is E1. E1 means ground state energy. Okay, so if you substitute a nu is frequency C by lambda, so you will get 1 by lambda equals to some minus E1. E1 means ground state energy of hydrogen atom by Hc into Z square 1 by Ni square minus 1 by Nf square. Okay, this E1 by Hc is what? E1 by Hc is Rydberg constant. Okay, E1 by Hc is Rydberg constant. This value is 0.9 10 to the power 7 meter inverse. Now, yesterday Atul sir told you that energy will be corrected due to finite mass. And since Rydberg constant, you see Rydberg constant is depends on finite mass. So whatever is the form of ion or energy, same will be coming for that Rydberg constant. So what I am saying, for finite mass, Rydberg constant will be mu by me into R infinity. R infinity means the Rydberg constant due to infinite nuclear mass. Okay. Now there will be that series, Lyman series. These things you people know. The first will be Lyman series. So for Lyman series, your Ni is how much? Sorry, NF will be how much? NF will be 1. Okay, and Lyman series that basically lie in UV region. Okay, so NF is 1, Ni can be 2, 3, 4, so on. Okay, so first line of Lyman series is known as L alpha. So L alpha means Ni is 2 and NF is 1. So for Lyman series, NF is fixed. So electron will jump from state 2 to 1, that is known as L alpha, 3 to 1 known as L beta, 4 to 1 L gamma, and so on. Okay, same is then you have Balmer series. So these things you know, but let me revise. So in Balmer series, that energy or wavelength of that emitted photon lie in basically visible region or visible range. Okay, for Balmer series, that Ni is how much? Sorry, NF is how much? 2 now, and Ni can be 3, 4, 5, so on. Okay, so that Balmer series lie in visible region. So NF, I mean final state is 2. So when that electron is making transition from 3 to 2, that is known as H alpha. So Balmer series, that line basically denoted by H. So first line is from 3 to 2, that is H alpha, 4 to 2 H beta, 5 to 2 H gamma, and so on. Okay, and the energy of emitted photon basically lie in visible range. Then you have Paschen series. So for Paschen, this the emitted photon of for this series basically lie in infrared range. Okay, infrared range. And for this line, when that electron making transition from transition to n equals to 3 from higher state, this is known as Paschen series. So for Paschen series, your final state quantum number is 3 and initial state quantum number can be 4, 5, 6, and so on. Okay, then you have bracket series. Again, this lie on higher range, and for this the final state quantum number or principal quantum number is 4, and when electron is making transition from Ni equals to 5, 6, and so on. Okay. Then you have Fund series. In Fund series, this basically lie in far higher range. So for this, that final state principal quantum number is 5 and initial state quantum number is 6, 7, 8, so on. Okay, so this is basic idea about your series, and I thought before doing any problem, I should do this part because this is important, because all this atomic is nothing but spectra. So this is your simple spectra. Then we'll go to fine structure. Then we'll see that effect of spin orbit coupling. We'll see that effect of magnetic field and so on. And nuclear effect also will observe. But this is the very basic introduction of spectra. So when that electron will make from transition from one state to another state, it will emit some lines or wavelength. The collection of these lines will be known as spectra. So it can be have two kind of spectra, and it can have different series, what I have discussed. Okay, so if you have done, then we should do for a problem, because already Atul sir derived problem based on that effect of nuclear finite nuclear mass and a hydrogen-like atom. So if you have done, we can go for problem. Shall I erase this? Shall I remove?
सर एक क्वेश्चन था
हाँ
सर इस सीरीज में जो H अल्फा लाइन H बीटा लाइन होती है
sorry, your voice is not clear.
हाइड्रोजन एटम में जो H अल्फा लाइंस और H बीटा लाइंस बताइए
हाँ
वो सर उसके लिए जो पर्टिकुलर वैल्यू है NiNF की वो
हाँ
किस
yes.
सीरीज के किस फॉर्म में लाई करेंगे
हाँ तो वही तो मैंने डिस्कस H अल्फा के लिए मैंने बोला ना, बामा सीरीज जैसे है, बामा सीरीज के लिए आपका फाइनल स्टेट फिक्स है. फाइनल स्टेट क्या है? n equals to 2.
यस सर
फाइनल स्टेट n equals to 2. तो H अल्फा लाइन के लिए क्या होगा आपका? जब 3 से 2 पे जंप करेगा उसको H अल्फा बोलते हैं. यही तो क्वेश्चन है ना, H अल्फा किसको बोलते हैं, H बीटा किसको बोलते हैं, यही क्वेश्चन है ना आपका.
सर H बीटा H अल्फा जो H गामा लाइंस होती है ना
हाँ
तो उनमें जो ट्रांजिशंस होते हैं तो उसमें सर Ni और NF की वैल्यू के बारे में
हाँ वही मैं बोल रहा हूँ. जैसे आपका मैंने ऑलरेडी बोल चुका हूँ, तब भी मैं बोल रहा हूँ. सपोज मान लो आपका, मैं ड्रॉ ही कर रहा हूँ, एक बार देख लो आप लोग. मैं स्पेस उतना ही करना हो, पहले स्पेस ज्यादा होगा फिर कम होता जाएगा. ठीक है, जैसे आपका सपोज मान लो स्टेट है, n इक्वल्स टू 1 है, n इक्वल्स टू 2 है, 3 है, 4 है, 5 है एंड सो ऑन. तो लीमान सीरीज के लिए जब 2 से 1 पे जंप होगा इसको बोलते हैं एल अल्फा. 3 से 1 पे जंप करेगा इसको बोलते हैं एल बीटा. 4 से 1 पे जंप करेगा इलेक्ट्रॉन इसको बोलते हैं एल गामा एंड सो ऑन. बामा सीरीज के लिए 3 से 2 पे जब जंप होगा इलेक्ट्रॉन इसको बोलते हैं एच अल्फा. 4 से 2 पे इसको बोलते हैं एच बीटा. 5 से 2 पे इसको बोलते हैं एच गामा. यही है ना, यही पूछ रहे हो ना आप?
यस सर
ठीक है. Okay, now shall we do free problem? So first problem is, suppose mass and charge of electron is double in hydrogen atom, then how much will be its ground state energy? So what I am saying, first question is very simple question. Suppose a hypothetical case where the charge of electron becomes double and its mass also becomes double, then what will be the ground state energy of hydrogen atom? So if you remember that yesterday's discussion, the ground state energy depends upon m e to the power 4, right? So yes. Now mass becomes double, it will be 2 me, charge will be double, so it's 16 times it will be right, because this factor, this becomes 2 me, it will become 2 to the power 4, 2e to the power 4. So it will come 16 Me e to power 4, and rest of the factor will be same. So the ground state,
32.
sorry, 32. It will be 32. Yes. So it will be 32. Now that new ground state energy will be how much? 32 into minus 13.6. Okay. Of course, that in unit will be electron volt. So if you calculate it, you will get minus 435.2 electron volt. Okay. Now if suppose mass of electron becomes twice mass of electrons, then what will happen to the ground state radius? What will happen?
म्यू का फैक्टर चेंज हो जाता
हाँ, नहीं, यहाँ पे म्यू का फैक्टर नहीं है, क्योंकि यहाँ पे जब हाइड्रोजन एटम की बात कर रहे हो तो फिर आपका मास उतना भी चेंज नहीं हुआ, ट्वाइस एम किया, आप कर सकते हो, बट मैं सिंपल बात कर रहा हूँ, अभी इफेक्ट ऑफ रिड्यूस मास की बात नहीं कर रहा हूँ, क्योंकि एम यहाँ पे भी ट्वाइस एम ऑलमोस्ट नेग्लिजिबल एज compared to nuclear mass. So what you will do basically in that case, because this at the end this mass is also very small, right, around on MEV, right? So this is also small. What I am saying, so you know that this radius of ground state is independent upon mass of electron, है ना? अगर ये मास बहुत ज्यादा बड़ा होता है, सपोज मतलब 100 टाइम्स एमई, तो आपको यू हैव टू इंट्रोड्यूस दैट कॉन्सेप्ट ऑफ फाइनाइट न्यूक्लियर मास, बट यहाँ पे ट्वाइस एमई इज आल्सो सिमिलर टू मास ऑफ इलेक्ट्रॉन, इतना भी बड़ा नहीं है. So just you have to substitute. Of course, if you introduce this factor, you will get answer, but it will take more time. So better this mass is small. You can use simple formula. So here that if mass becomes double, so that radius will be 1 by 2 times that radius of ground state of hydrogen. So यहाँ पे कितना हो जाएगा? Modified जो आपका radius हो जाएगा वो simply a naught by 2 हो जाएगा. समझ में आई ये? समझ में आई?
यस सर.
Okay. Now what is positronium?
क्या सर?
Positronium क्या है?
दोनों इलेक्ट्रॉन का बनाया था.
हाँ, positronium means you have positron at a nucleus and electron is revolving. So this is known as positronium. Then you have muonium. What is muonium? Mu plus is sitting at nucleus and electron is revolving. This is known as muonium. ठीक है. एक आपका होता है म्यूनिक हाइड्रोजन. म्यूनिक हाइड्रोजन में क्या होता है आपका? प्रोटॉन इज सिटिंग एट न्यूक्लियस एंड mu particle, mu lepton, it is revolving. So this is known as muonic hydrogen. Sorry. Now my first question is, how much energy is required to excite an electron from ground state to first excited state in positronium system? So you have positronium system initially at ground state. So how much energy is required to excite the electron from ground state to first excited state? Can you be able to solve? So you have positronium system, right? So energy formula for finite mass, let us denote by En dash. So that will be how much? If you remember, mu by Me into En, where En is the nth state energy of hydrogen atom, and this is the correction of energy due to finite nuclear mass. Now we have positronium system, so its reduced mass will be how much? Simply Me by 2, right? No?
Yes,
Is
sir.
it clear? For positonium system, that reduced mass will be mu by 2 because your positron and electron both have same mass. So mu will be me into me divided by twice me. So me will be cancelled. So simply mu is me by 2. Now if you substitute that mu here, me by 2, so it will become en by 2. Okay. So the ground, let me calculate ground state energy of positonium system. So it will be how much? Eon dash equals to Eon by 2. And first excited state means E2 dash E2 by 2. So energy required to excite that electron from ground state to excited state will be how much? Simply E2 dash minus Eon dash, right? So if you see E2 dash is how much? E2 by 2, Eon dash is Eon by 2. So 1 by 2 will be common. Then E2 minus Eon. And you know E2 by Eon, right? And E2 and Eon. For E2 is first excited state energy of hydrogen atom. Eon is ground state energy. So it will be 1 by 2 into minus 13.6 by 4 plus 13.6. Okay. So if you calculate it, it will be how much? 5.1 electron volt. Is it clear? Is it clear?
Yes, sir. सर वो राइट हैंड साइड का आपने क्या लिखा है सर बोर्ड पे थोड़ा सा कम विजिबल था
ये वाला पार्ट
हाँ 1/2 minus 13.6 by
4, because this is the ground first excited state energy of hydrogen atom. So 13.6 by n square, right? N is 2 here. Then you have ground state energy. So minus minus plus 13.6, and of course that
Yes, sir.
unit will be electron volt. Okay.
yes sir
Okay. Now again similar question. Suppose Rp represent radius of positonium for nth state. So this is your Rp. This is radius of positonium okay for nth state. Then RH you have, R is the radius of hydrogen of nth state. And EP is the energy of positonium for nth state, and EH is the energy of hydrogen for nth state. ठीक है, तो रेडियस positonium system का RP for nth state, RH is the radius of hydrogen atom for nth state, EP is the energy of positonium for nth state, and EH is the energy of hydrogen of nth state. Now can you correlate between EP and EH? Can you calculate that ratio? EP by EH is how much, and RP by RH will be how much, that ratio? Question is clear?
yes sir सर वो पोजिट्रोनियम एटम के लिए है ना
हाँ, ये positonium के लिए है RP, है ना, और H मीन्स हाइड्रोजन एटम के लिए है.
तो EP by EH हो जाएगा 1/2
4/2
सर 1/2
1/2 good. And RP by RH
2/2
so RP by RH, let me calculate RP by RH. So Rn dash, due to finite nuclear mass, that radius of a system will be how much? Me by mu, right? Me by mu into the radius of a hydrogen atom, you can say. Okay. So and let us define this. This term is RP here. So RP will be how much? that energy reduced mass, you know, for positronium reduced mass is how much? Me by 2 into RH. So me will be cancelled. It will be twice R of H. And energy we have already calculated. So EP will be how much? Mu by Me into E of H. And mu already know, so it will be EH by 2. है ना? अब दोनों का स्पीड का क्या फैक्टर होगा बताओ? VP by VH कितना हो जाएगा?
सेम ही होगा.
सेम होगा.
हाँ?
1.
Good.
Same.
Because speed is independent on reduced mass. Okay. So if you see that form of speed for finite nuclear mass of nth state is how much? It is same, right? So there is no effect of finite nuclear mass on speed of electron or that orbiting particle. Okay. Is it clear? Now I'll give one problem. इरेज कर सकते इसको?
Yes, sir.
So suppose you have muonic system. So you have to calculate that energy of L alpha, L beta, and L gamma line. You have muonic system. You have to calculate the energy of L alpha, L beta, and H alpha line. Can you able to solve? So muonic system means you have proton and electron. Mu particle is orbiting. Okay. Mass of proton is given. Mass of proton is 1836 times mass of electron, and mass of mu particle, mu minus, is given as 207 times mass of electron. And what they have asked, the energy of L alpha line, L beta line, and H alpha line. Can you able to solve?
Yes, sir.
How will do? So you have to calculate reduced mass first, right? So reduced mass will be how much? 1836 Me. Then you have 207 Me divided by 1836 Me plus 207 Me. Okay. Can you calculate it? So if you calculate it, I have calculated, you will get approximately 186.03 mass of electron. On 86.03 mass of electron times mass of electron. Now you can calculate that energy of nth state, right? So energy of nth state will be how much? Due to finite mass, let us denote this notation En dash. That will be mu by Me, energy of nth state of hydrogen atom. Okay, and that thing you know, minus 13.6 by n square. Okay, and you have to multiply it by 186.03. Okay, so L alpha line means n from which state to which state? 2 to 1, right? And L beta means 3 to 1, right? And H alpha means what?
3 to
3 to 2. So that energy of first, second, and third state you have to calculate. So what I am saying, you have to calculate that energy of L alpha, L beta, L gamma, H alpha line. You have to calculate the energy of ground state, first excited state, and third second excited state. Can you be able to calculate it? Very simple. So E1 dash will be how much? Minus 186.03 times 13.6, right? So if you calculate it, I have calculated, you can check, minus 2529.9 electron volt. Similarly, if you calculate E2 dash, first excited state, so this factor will be 2529.9 divided by 4, right? Because by n square it will be by for first excited state, that factor will be divided by n square. N is how much here? 2. So 2, if you 2 square means 4. So if you have to divide basically by 4. So it will be how much? Minus 632.4 electron volt. Now E3 dash will be how much? So it will be minus 2529.9 divided by 9, right? Did you get what I'm saying? Is it clear?
Yes, sir.
So how much it will be if you calculate it? Minus 281.1 electron volt. So you have calculated that energy of ground first and second excited state. Now you can calculate that energy of L alpha line, L beta line, and L gamma line, right? So if you calculate it, please calculate. So energy of L alpha, for L alpha, the energy will be how much? E2 dash minus E1 dash. Okay. So if you calculate it, E2 dash minus E1 dash will give you 1897.5 electron volt. Okay. L beta line energy will be how much? So it will be E3 dash minus E1 dash. Okay. So if you calculate it, you will get 2248.8 electron volt. Then H alpha will be how much? E3 dash minus E2 dash, right? So if you calculate it, you will get 3.51.3 electron volt. Okay. Is it clear? हाँ. लिख लिया आप लोगों ने?
Yes, sir.
Yes, sir.
Now suppose electron is the third Bohr orbit of hydrogen atom. Electron is the third Bohr orbit of hydrogen atom. Can you tell me what will be its de Broglie wavelength?
Sir, can you please repeat the question?
Electron is at third Bohr orbit of hydrogen atom. Can you tell me how much will be its de Broglie wavelength? So electron is where?
Sir,
Hydrogen. Yes.
Sir, energy से momentum calculate करेंगे and then wavelength.
You can do this, no problem. But it's a very simple. You can do this. See, n is what? Third Bohr orbit means n equals to 3. So Rn will be how much?
H by lambda करते हो.
N square a naught, right? N square a naught. N is how much here for third? N is 3, so it will be 9 a naught. Okay, and you know n a naught. A naught is how much? 5.3. Let us assume a naught is 5.3, 0.53 angstrom. So it will be 9 into 0.53 angstrom. Okay, so 9 into, can we write like 5.3 into 10 to the power minus 11 meter, right? So if you calculate it, I have calculated 47.7 meter. Okay, so this is your R. Now you know 2 pi r equals to n lambda, right? 2 pi r equals to n lambda. Here n is how much? 3.
3.
So lambda will be how much? 2 pi by 3 into r. Okay. So 2 pi by 3 into r is, sorry, here I missed that factor. So 47.7 into 10 to the power minus 11 meter. So 47.7 10 to the power minus 11 meter. So if you calculate it, you will get 99.9 10 की power minus 11 meter. Okay, is it clear?
Yes, sir.
Okay, now suppose I'll ask one more question. Suppose electron in hydrogen atom. First of all, hydrogen is at rest. Hydrogen atom is at rest. Initially, electron is in n equals to 5 state. Initially, electron is at n equals to 5 state, and it makes transition from 5 to nf equals to 1. Did you get? Hydrogen is at atom is at rest. Initially, electron at ni equals to 5, it is making transition from 5 to n equals to 1. Now, can you tell me how much will be the recoil speed of hydrogen? How much it will be?
We
Can you tell me?
calculate-
Huh?
We can calculate by applying conservation of momentum.
Conservation of?
Momentum.
Good. So you have to calculate first energy, right? Energy of emitted photon.
Yes, sir.
Then you can calculate that momentum of photon, and momentum will be conserved. So we have to apply that photon, the formula. So the energy of emitted photon will be how much? E gamma. Let us denote that notation E gamma. So E gamma will be basically how much? E gamma will be how much? E5 minus E1, right? So E5 is nothing but minus 13.6 by 25, and E1 will be how much? Simply 13.6. So basically 13.6 into 24 by 25 electron volt, right? So if you convert it into joule, so 13.6 24 by 25. So from electron volt to joule, you have to multiply by 1.6 into 10 to the power minus 19. Then it will be converted to joule. So if you calculate this, that energy of emitted photon will be how much? 2.1 into 10 to the power minus 18 in joule. Okay. So now you calculated that energy of photon. So that momentum of photon will be simply E gamma by C, right? So is it clear? So I've calculated that energy of emitted photon due to transition from n equals to 5 to n equals to 1. Energy I have calculated. Now when that electron is at n equals to 5, the atom was in at rest. So it has momentum 0. But when that photon is emitted, photon carrying some momentum, right? So that atom should recoil in opposite direction, right? No. So before, so what I'm saying that initially rest, so energy momentum was 0. So if you apply that momentum conservation, so after emission of photon, that momentum will be how much? Let us denote that notation pH plus P gamma, where pH is the linear momentum vector of hydrogen atom and P gamma is the linear momentum of emitted photon. So P gamma in vector form, they are in opposite. So what does it mean? If photon is moving in this direction, the hydrogen should move in opposite direction, but their magnitude will be same. If you take magnitude, it will be same. So pH will be how much? Simply P gamma, and P gamma you know, E gamma by C, and pH is nothing but mass of hydrogen atom into velocity, because it's a linear momentum, so it will be E gamma by C. Okay, and so speed will be how much? E gamma is 2.1 into 10 to the power minus 18. Then you have mass of hydrogen is 1.67 into 10 to the power minus 27 kg, because this is only about that proton, right? Then you have speed of light, that is 3 into 10 to the power 8. Okay, so if you calculate it, the speed will become 4.19 meter per second. So it will be 4.19 meter per second. Now I'll ask an interesting problem. So ये हो गया, आपने लिख लिया?
Yes.
I'll ask on more problem. Now suppose electron in the nth Bohr orbit, आपका न्यूक्लियस है, इलेक्ट्रॉन nth Bohr orbit में रिवॉल्व कर रहा है मानो, ठीक है ना? तो magnetic, it will create magnetic field at the center of nucleus, right? So when that electron is revolving, so how that magnetic field is depends upon principal quantum number. How will the relation? How it will vary with principal quantum number? Did you get my question? Suppose
Sir,
electron
yes,
is revolving. Suppose electron is revolving in nth Bohr orbit. Okay. Now, how that magnetic? It will create magnetic field at the center of nucleus, right? When it will revolve, because ultimately electron is charged particle, so it will create some current, right? So this current will be current due to at the center of the circle is how much? So electron is revolving at nth Bohr orbit. So how the magnetic field at the center of nucleus will vary with principal quantum number? That is the question. Electron is revolving at nth Bohr orbit. So how that magnetic field at the center of nucleus will vary with principal quantum number? This question is clear?
Yes, sir.
Sir.
So how will do it? So since see when the electron is revolving, so it basically it will produce current, right? So current magnetic field at the center of that circular loop is how much? Mu naught
I by 2.
exactly, mu naught I by 2 what? And I is how much?
E by
by
T.
T.
2 pi r by.
Good. So E by T. And T is how much? 2 pi r by
2 by
V,
R by
right?
T.
So it will be EV by 2 pi r, right? I goes to EV by 2 pi r. Now you see magnetic field is proportional to, now become, these are all are constant. It is independent on principal quantum number. So basically you see it depends upon V by R square. And we know V is inversely proportional to 1 by N, right? And R is proportional to N square.
Yes, sir.
So we can say that magnetic field varies with principal quantum number like 1 by n to the power 5. Is it clear question? ये समझ में आया? Did you get?
Yes, sir.
Because ये फैक्टर क्या
Yes.
देगा V 1 by n और आपका R square, R varies with n square, right? As a n square, so it will create n to the power 4. So ultimately 1 by n into n to the power 4. So magnetic field at the center with varies with principal quantum number like 1 by n to the power 5. Is it clear? Is it clear?
Yes, sir.
Okay. Now एक चीज बताओ, सपोज मान लो you have hydrogen atom in a second excited state. Suppose you have hydrogen atom in second excited state. Then you have lithium double plus ion. This is also in second excited state. And let us denote that angular momentum of hydrogen atom in second excited state is LH, and angular momentum of lithium in second excited state is Li. ठीक है, अब कौन सा बड़ा होगा? क्वेश्चन क्लियर है? हाइड्रोजन एटम is in second excited state. Lithium double plus also is in second excited state.
लिथियम का बड़ा.
Any more question answer?
सर हाइड्रोजन का रिलेटिवली होगा,
लिथियम का ही बड़ा होगा सर।
हाइड्रोजन का बड़ा होगा।
हाँ वो तो आपका ध्यान में ऐसे आएगा ना कि जेड का फैक्टर
तो
आएगा।
लिथियम का मास
Yes,
मास
yes.
ज्यादा है ना सर।
नाउ सी क्वेश्चन मैंने
Hello?
इसीलिए पूछा हूँ। यस
नहीं 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 सर,
क्वेश्चन एक
इक्वल
बार आप
होगा सर,
रिपीट करेंगे
सॉरी
इक्वल होगा।
क्वेश्चन
NH
रिपीट
के
करेंगे
बराबर
आप
होता है
एक
ना
बार
angle।
हाँ यस यस क्वेश्चन आई एम रिपीटिंग। सपोज you have hydrogen atom that is in second excited state. Lithium double plus, it is also in second excited state. Now let us denote that angular momentum of hydrogen is in hydrogen atom is in second excited state, that is LH, and for lithium double plus that angular momentum corresponding to this state is small l subscript li. So इनमें से कौन सा एंगुलर मोमेंटम बड़ा होगा? क्वेश्चन क्लियर है?
बराबर होगा दोनों सर, बराबर होगा दोनों।
गुड, बिकॉज एंगुलर मोमेंटम of any state is nothing but NH cross. NH cross, right? So for this also it will become LH will be how much? 2H cross, and this will also be LI will be how much? 2H cross. Is it clear? So कोई
Yes,
भी
sir.
स्टेट का अगर हाँ कुछ भी दे दे आपका वो जस्ट प्रिंसिपल क्वांटम नंबर के ऊपर ही डिपेंड करेगा, ठीक है? Is it clear? क्वेश्चन आंसर
Yes, sir.
क्लियर है ये?
Yes, sir.
Okay. Now suppose you have electron in hydrogen atom at n equals to 5. Okay. So how many emission line you will observe? अगर सपोज मान लो इलेक्ट्रॉन n equals to 5 स्टेट में है तो कितना इमिशन लाइन आप देख सकते हो? How many lines you will observe in spectrum?
Sir, 4.
and 4
No.
16।
No. So very that formula we learned in our 12th class also, right? N into n minus 1 by 2. You can see also. So it will be basically 5 into 4 by 2. So it will give you 2. You will get 10 lines. I'll show you also. Okay. So how will observe? So n equals to 5. You can draw line. So this is on 2, 3, 4, 5. On 2, 3, 4, 5. So electron can jump from here to here. It will give one line. Here to here, it will give another line. Here to here, it will give another line. Here to here, it will give another line. Here to here, it will give one line. Here to here, it will give another line. Here to here, it will give another line. Right? Similarly, from here to here, it will give one line. Here to here, it will give one line. Here to here. So on 2, 3, 4, 5, 6, 7, 8, 9, 10. Is it clear? Is it
Yes, sir.
clear?
Yes, sir.
सबको समझ में आई है? So formula भी यूज कर सकते हो आप for any state n into n minus 1 by 2. ठीक है? Is it clear?
Yes, sir.
Yes.
Now suppose you have muonic hydrogen. Suppose you have muonic hydrogen. तो जो लाइमन सीरीज का लोएस्ट वेवलेंथ कितना होगा? Suppose you have muonic hydrogen. So I'm not defining what is muonic hydrogen here. Okay. So what will be the
अतुल सर क्लास नहीं लेंगे सर?
हाँ
अतुल सर क्लास नहीं लेंगे सर आज?
हाँ तो सर लेंगे क्लास, तो शायद टाइम हो गया, राइट?
हाँ सर, तभी मैं पूछा था कि उनका टाइमिंग हो गया ना।
चलो ठीक है, फिर कल करते हैं, अभी प्रॉब्लम है ना, कि अभी तो जस्ट इजी क्वेश्चन ही आप लोगों को दिया हूँ, फिर
सर
कल
वो
करते
पता
हैं।
नहीं टाइमिंग उनका अलग दे रखा है सर, 8:25 का है, तब तक तो आप पढ़ा सकते हैं।
अच्छा दूसरा क्लास आप लोगों का होगा शायद।
EMT का है सर।
हाँ सर,
चलो ठीक
अभी
है,
तो EMT का क्लास।
चलो
Yes,
फिर
sir.
ठीक है,
Thank you,
कल
sir.
ओके ठीक है,
ओके,
Thank you, sir.
वेलकम।